All right, here we go. The last time we're ever going to talk about limits. Sorry about that. The last time we're ever going to talk about limits, I'm going to show you the three examples. I'm going to give you a quiz on it, and then we're going to be done. I need to be finished. Let's do just a little bit of adjustment. There we go. So here are the rules, right? Step one, we just go ahead, and if we see a limit, the limit as x approaches 1 of this function here, we can input the 1 for x. Well, if we input the 1 for x, we actually get 0 over 0. I'll show you that in a minute. If the denominator ends up being 0, then we have to factor. Okay, and then we're going to factor whatever we can and cancel whatever we can, and then we'll be able to input that value for x, and then we'll be able to solve. So let's go ahead and get started. Here we go. The limit as x approaches 1 of x squared minus 1 over x minus 1. Now, we see already that we have something factorable on top, but just for fun, let's do step 1. Step 1 says, we'll just go ahead and input that 1 where we see the x over 1 minus 1. And what do we end up with? 0 over 0. That is completely undefined. That doesn't exist. So we're going to have to do step 2. So step 2 says factor what you can. Well, we can factor x squared minus 1 because that's a difference of squares. Remember, it's a difference of squares. A perfect square on either side and a minus symbol in between. So what that is x minus 1 times x plus 1. And if we FOILed that out, we would get x squared minus 1 all over x minus 1. And what we'll do then is cancel, right? And that's part of that step 3.
Good afternoon.
Cancel what we can.
Or 2 announcements.
Hang on for
First,
Katie
there's
Ford.
a mandatory spring soccer meeting in room 211 during life skills today. All spring soccer players must attend. All other cadets here to report directly to the gym when the bell rings for the basketball game.
And here we go. I have x plus 1, so now I'm going to input that 1 for x, and 1 plus 1 equals 2, and that's our limit. So the limit of this function is 2. And what it means is there's a hole right there at x equals 1, but we're approaching 2 from both sides, okay? The next one, just as simple. I'm going to move this just a little bit, give myself a little bit more room. If I input the 5 into this, the limit as x approaches 5 of x squared minus 5x over x minus 5. If I input the 5, right, I get 5 squared minus 5 times 5 over 5 minus 5. And what do I get? Well, of course, I get a 0 over 0. It's undefined, right? All right, well, I have to do work. Well, this is factorable, right? There's an x squared here and a 5x here, so I can factor out an x. So I'll take out an x. I'll divide x squared by x, and that's x. 5x divided by x is 5. Oh, that looks nice and fancy. All over x minus 5. And then just like it says in step 3 over here, I'm going to go ahead and cancel what I can, and what I'll be left with is x. And the last step there is go ahead and input that value for x. And what do I get? 5 is my limit. Okay, and again, you would see a hole. If you looked at the graph, it would be a straight line with a hole at x equals 5. Last but certainly not least, same idea. We're going to keep doing the exact same thing. Well, I'm going to have to do this underneath because I don't have quite enough room, but I'm going to go ahead and input the negative 5 squared plus 3 times negative 5 minus 10, and that equals 0, right? Because negative 5 squared is 25, plus negative 15 minus 10, so it's 25 minus 25 basically, and that equals 0. Negative 5, should have put it on the inside, Harry. All right, negative 5 plus 5 gives me a 0. So I can't do that. I'm going to have to factor. And remember, when we're factoring, and it's something that we don't necessarily know off the top of our heads, this guy down here is going to give us a clue. More trouble, and we'll have to do a lot more work. But let's assume that that's what this guy right here, this is going to be one of our binomials when we factor the numerator. All right, so if that's one of our factors, if we know that x plus 5 is going to be one of our binomials, what times 5 gives me negative 10? That would be negative 2, right? And so let's just do the math here. 5x minus 2x, that gives me 3x. Yeah, we did our job the right way. And then we'll just leave our x plus 5 in the denominator and cancel. What we'll be left with is x minus 2. We'll go ahead and input this negative 5 into our new binomial. Negative 5 minus 2 is negative 7. And that's our limit. And that's what you're going to have to do tomorrow. That is all there is to it. This is the last thing we're going to do before we start reviewing. This is your first shot at doing calculus. This is getting you ready for next year. Thank you very much for watching, and enjoy this video. You're going to take a quiz on this very, very soon.